Okay, 7.2 takes over where 7.1 left off. So in the last example that we saw in 7.1, we were told that the area, within a certain region was a certain amount, and then we were asked to interpret that. And the interpretation is that the area is equivalent to the probability, right? Or the proportion. And for that, we're going to use StatCrunch, okay? So we're going to go to stat and then calculators and then normal. So remember when we wanted to compute probabilities involving the binomial variable, we went to stat, calculators, binomial. Now we want to compute probabilities involving the normal variable, so we go to stat, calculators, normal. And when you go there, you'll be prompted to enter something for the mean and something for the standard deviation, okay? And then, of course, you'll want to enter the probability that you're looking for. So let me give you an example. This one says the weights of giraffes are approximately normally distributed with mean 2,200 pounds and standard deviation 200 pounds, just like that example we saw at the end of 7.1. And then part A says draw a graph that shows the area under the normal curve left of 2,000 pounds. We've actually kind of drawn something like this, but I think in the example in 7.1, we were drawing the area to the left of 2,100 pounds. So it's a little different. But anyway, here's the mean. 1 standard deviation above, 2 above, 3 above, and then 3 below. And we want the area to the left of 2,000 pounds. So that would be this area right here. Now, you'll notice that 2,000 pounds happens to be exactly 1 standard deviation below the mean. Which means in part B, when they ask us to convert 2,000 to a z-score, I'm gonna guess that the z-score is -1 because we're 1 standard deviation below the mean, and that's exactly what the z-score is supposed to measure. But just to confirm it, we can use our z-score formula and say z equals x minus mu over sigma. X in this case is 2,000. Mu, our mean, is 2,200. And sigma, our standard deviation, is 200. So this is -200 over 200. Sure enough, it's -1. Part C is a blast from the past. It says use the empirical rule to find the probability that x is less than 2,000. Well, the empirical rule, remember, this is the one that said that 68% of the data is within 1 standard deviation and so forth. If you split that 68 in half, then that means 34% is here. And maybe instead of labeling this 34%, I'm just going to say from here on is 50%, right? Because this is a symmetric distribution. So to the right of this line, you should have 50% of your data, and then to the left, you should have 50%. So really, what's shaded in here is 50% of the data minus this 34% that's not shaded in. So I'm going to say probability that x is less than 2,000 is going to be approximately 50% minus 30, and that's 16%, I think. So, so I'm going to guess 16%. Now, part D. This is the new stuff, right? Now it says use StatCrunch to verify your answer in part C. So let's do that. We're going to go to stat, calculators, normal. When we get there, we're going to put in mu equals 2,200 and sigma equals 200. And then we're going to look for the probability that x is less than 2,000. Let's see what we get. So stat, calculators, normal. Mean is 2200. Standard deviation is 200. And we want the probability x is less than 2000. Now, you may be a little bit distressed about the fact that this is a less than or equal to. So you might click on that and see, oh, there are only two options. Remember when we looked at the binomial variable, there were like 5 different options, right? Including an equal sign and a whole bunch of stuff. Here we only have 2 options. Now, the reason that we only have 2 options here instead of like 5 options is because, as we said, the probability that x equals some value is always 0. So you're not, so it's kind of pointless to have, you know, an equal sign available for the normal calculator. But it's also redundant to have both a strictly less than and a less than or equal to sign in there, since those two things are equivalent when you're talking about a continuous variable, right? I mean, the probability that, in this particular case, the probability that x equals 2000 is 0. So this little equals sign down here, it's not contributing anything to the probability. If we got rid of the equal sign and just looked at the probability x is strictly less than 2000, it's going to give us, it's going to be the exact same answer. Anyway, the moral of the story is you don't have to worry about there not being an equal sign here or whatever, right? If you're looking for the probability x is less than 2000, that's equivalent to looking for the probability x is less than or equal to 2000 in the case that you have a continuous variable like we do here. Anyway, so you hit compute and there's your answer. If you round this to 2 decimal places, you get 0.16, just like we got when we used the empirical rule. We can be a little bit more exact here and say that it's about 0.1587. Okay, that's still pretty close. Okay, so pretty close, right? Pretty close. What we got from StatCrunch is better, right? It's more accurate. Part C, or Part E, it says, now use StatCrunch to find probability x is less than 2100. So we will, and note that the empirical rule would not help us to solve this problem. Because if we're trying to find 2100 is right here between 2000 and 2200, the empirical rule doesn't help us with that, because the empirical rule doesn't tell us how much of the data is within half a standard deviation from the mean, right? It doesn't tell us anything about that. So we'd be stuck without StatCrunch on this particular problem. So we're going to do the same thing. Go stat, calculator's normal, mean is 2200, standard deviation is 200, and this time we want probability x is less than 2100. And we get 0.3085, which should look familiar to you. That was the probability that we were just given in 7.1, right? Like in 7.1, they just told us in part B that that was the area, right? 0.3085, and now we've just confirmed that. So there you go. That's how you find probabilities. That's how you find normal probabilities in StatCrunch. So if you've got a normal variable on your hands, then you use StatCrunch to find probabilities involving that normal variable. One thing that might bother you about this is that we haven't talked about how to determine if the variable is normal in the first place, right? Like when we talked about discrete variables, we said, well, first you have to determine if the variable is binomial, and then if it is binomial, then you can use the binomial calculator. If it's not binomial, then you just have to do some of the work by hand, right? Same thing goes for normal distributions. You can't just assume that a variable that you're handed is normally distributed. It might not be. So we're going to talk in 7.3 about how to determine if a variable is normally distributed. Before we get to 7.3, we're going to take a little detour and do 4.1 and 4.2, because the way that we determine if something is normally distributed is really similar to determining if there's a linear correlation between two variables, and that's what the topic discussion is in chapter 4. So, so we will come back and talk about how you can determine if something actually is normally distributed so that you're justified in using the normal calculator in StatCrunch. But for now, you'll probably just be told that this variable is normally distributed, and so then you're safe to go ahead and use the normal calculator. Let me just give you another couple examples. This one says a pediatrician obtains the heights of her 200 3-year-old female patients. The heights are approximately normally distributed, so you can use the normal calculator, with mean 38.72 inches and standard deviation 3.17 inches. Determine the proportion of 3-year-old females that will have a height less than 35 inches. So I'm just going to go ahead and say, like on all of these parts, we're going to do the same thing. Stat, calculators, normal. And we're going to use the same mean and standard deviation for all of them, right? The mean on all of them is 38.72. And the standard deviation on all of them is 3.17. In part A, we want the probability that the randomly selected girl is shorter than 35 inches. Okay, so we want probability X is less than 35. And by the way, on tests and quizzes and stuff, I want to see you write out this probability notation. I need you to write it out for me. Okay, so write out exactly what I'm writing here. But let's see what we get. I'm going to start over and go stat, calculators, normal. The mean is 38.72. The standard deviation is 3.17. And then we want the probability that X is less than 35. So you hit compute, and there you go, right? You'll notice that it shades in exactly the probability that we're looking for. Maybe before I go back to the page, I'll point out that these are not the standard deviations or the mean, right? Like the mean was 38.72, and they didn't even label that here. What they've put here on the x-axis is just some convenient values, right? Like going by 5s. If you want them to actually put the mean and standard deviation on the graph, then you can click on this thing that says 68, 95, 99.7 ticks, and then it gives you the mean, and then 1 standard deviation above, 2 above, right? 1 below, 2 below, 3 below, and so forth. But there we go. So there's our probability. So it's about 0.1203. Okay. In part B, we want the probability that she's greater than 35 inches. Also, that should just be a matter of switching the inequality around, right? And you'll notice that this is the complement to that, right? The white stuff is the complement to the red stuff. And so it makes sense that this probability is just 1 minus what we got in part A. But anyway, 0.8797. Part C asks us for the probability that X is between 35 and 37. We're going to write this exactly the way it looks, right? We want X to be between 35 and 37. Okay, let's see what we get. Just like with the binomial calculator, if you want to do between probabilities, then you need to put it in the between mode. And I'm looking for the probability X is between 35 and 37. And there you go. They're giving us this area, which corresponds to this probability, right? 0.1734. Okay. And then last but not least in part D, we're looking for the probability X is less than 35 inches or greater than 37 inches. So we're looking for the probability that X is less than 35 inches or that X is greater than 37 inches. Now, there are 2 ways you could think about that. Well, I mean, there are multiple ways that you could think about any of these problems, but this one in particular, there are a couple ways that you could think about this. So first of all, to draw a picture, right? So let's say, you know, 35 is there and 37 is there. In part C, we found the area. We found the area between those values, right? In part D, we're being asked for the complement. So one way that you could do this problem is to just realize that this is the complement of that. And so you could say, oh, well, so this is just 1 minus the probability that x is between 35 and 37. And so that's about 1 minus 0.1734. Right? So that's one way you could do it. The other way you could do it, is to realize that this OR is going to turn into addition, right? And so you're just going to have probability x is less than 35 plus probability x is greater than 37. And you can go into StatCrunch and figure out this probability, which we've already done, right? We know that that's about 0.1203. And you can go into StatCrunch and get this probability, which we haven't done. So let's do that. Okay, probability x is greater than 37 is 0.7063 approximately. Okay, and then when you add these up, you should get the same thing as you would get if you were to do this subtraction right here. Like in both cases, I think you're going to get the same thing. Let's see. 1 minus 0.1734 is 0.8266. And 0.1203 plus 0.7063 is also 0.8266, right? Both of these things equal 0.8266. Obviously, you don't have to do it both ways every time you encounter this sort of scenario, but I just wanted to show you that you could think of it in more than one way, and that's totally fine. So, so that's that one. Now, earlier on in the course, I said that we would come back to the concept of percentiles when we had better tools to be able to compute them. Well, we have better tools now. So we're going to talk about percentiles again. Percentiles are basically just probability problems like this, only you're being asked to work in reverse. In other words, just as a reminder, if the area to the left of an observation is k%, then that observation is at the kth percentile, right? So if you scored an 1100 on the SAT and that's in the 65th percentile, then that means that you scored that 1100 is better than 65% of scores, right? Anyway, so when you're given a percentile, what you're actually being given is the area, right? and then you're asked to find what value corresponds to that. So to give you an example, so referring back to the pediatrician example, right? Like all this 3-year-old female girl height thing. It says find the height of a 3-year-old girl at the 20th percentile. So find the height of a 3-year-old girl at the 20th percentile. When they give us the 20th percentile, they're giving us the area. They're giving us the probability, right? In other words, they're asking us probability that x is less than what value is equal to 20%, right? So unlike the previous problems where we were looking for like probability x is less than 35 is equal to what, now we're looking for probability x is less than what is equal to 20%. Okay, StatCrunch will do this for us though, so it's not a huge deal. StatCrunch will do this. So same thing as before, right? We go stat, calculators, normal. We're gonna put in mean equals 38.72 and sigma equals 3.17. And then we're going to punch in exactly this, right? We're going to leave this part blank and punch in 20%. Okay, so let's do that. Okay, so here we are in the normal calculator. I want the area to be to the left. I want this value to be blank because I want StatCrunch to fill that in for me. And I want the probability to be 20%. Okay, so I do that, hit compute. And there you go. There's the value. I'll round this to the nearest whole number. So in this case, it would be about 36 inches. Okay? So here's what I'm going to say. Like if I call this, oh, I don't know, if I called it like A or something like that, then I would say, all right, so A is about 36 inches. Okay? Part B says find the height of a 3-year-old girl at the 85th percentile. Same thing. We want this area to be 85% now. So we need to see what value corresponds to an area of 85%. So I'm going to delete that, change this to 85, and there you go, about 42 inches. Okay, so B is about 42 inches. Okay, so in other words, if a 3-year-old girl is 42 inches tall, then that means that she is taller than 85% of 3-year-old girls. If she's 36 inches tall, then that means she's taller than 20% of 3-year-old girls, or in other words, she's shorter than 80% of 3-year-old girls. This girl is shorter than 15% of 3-year-old girls, right? So that's the idea there. And then part C, it's not asking us a percentile question because this area is going to the right. Okay, so it's not asking us actually for the 4.95 percentile. It's actually asking us for the 95.05 percentile, okay? But anyway, we can do this in StatCrunch the same way. We just want the area to go to the right, and then we're going to put in the area that we want, right? 0.0495. Okay, and that value looks like it's about 44 inches. Okay, about 44 inches. Okay, and that's that. Okay, so that'll do it for 7.2.